Hello, everyone. Welcome back. Today, I'm going to be talking about how to find the asymptotes for any function. Last time we talked specifically about reciprocal functions and how we know where the asymptotes are and how we know if there are asymptotes there, but that certainly was not an exhaustive list. And today I'm going to be giving you kind of a more exhaustive list of how we know where there are versus aren't any asymptotes. Okay, so let's start with the first one, which is vertical asymptotes. So if we have a graph, f of x equals h of x over g of x, then it has a vertical asymptote at x equals a, where g of x is equal to 0, right? So this is very similar to what we talked about with reciprocal functions. The only difference is that if there is a term, right, if there is a term that can be canceled out with a term at the top, then it's actually a hole that occurs there, right? So it says here, in other words, vertical asymptotes of a function occur when the denominator is 0, but there's one exception here that we didn't have to worry about with reciprocal functions that we do need to be aware of here, where if the numerator and denominator are equal to 0 at x equals a, meaning there's something that we can cancel out because the numerator also is equal to 0 there too, that means there is a hole at x equals a, not an asymptote. So that's pretty much the only exception that we've got to watch out for. That wasn't really a concern when it came to the reciprocal functions because it was always just 1 over, something, blah, 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 1 over something. And so there was no, there was not actually a function at the top. And so there wasn't a part of the function that could also make 0 in any way. But when it comes to, function over function, that is possible. So we do need to look out for that. And I'll get to examples of that very soon too. What about horizontal asymptotes? So basically, we have a horizontal asymptote at y equals 0 if the degree of the denominator is higher than the degree of the numerator. And so that's why every single time when we did our reciprocal functions of linears and of quadratics, we had the asymptote of y equals 0, that horizontal asymptote, because if the degree of the numerator is just 0, because the only thing in the numerator is 1 in our reciprocal functions, and the degree of the denominator is 1, which is larger than 0 when it comes to linears, and 2, which is also larger than 0 when it comes to quadratics, then we're always going to be in this category. So that's why last time, we learned that it was y equals 0 for all those cases we did. So it was always this category. Now, what are the other categories when it comes to function over function? Well, if the coefficient, if the degree of the numerator and the degree of the denominator are the same. So, for example, if we have linear over linear, or quadratic over quadratic, or degree 3 polynomial over degree 3 polynomial, if we have anything like that, anything where the degrees are the same in both numerator and denominator, then we take the coefficient of the leading term, so the coefficient of the highest degree term or leading term in the numerator, over the coefficient of the highest degree term in the denominator. Okay, so we just look at those coefficients, and then that coefficient over the other coefficient is going to be where our asymptote is. And then C says there is no horizontal asymptote if the degree of the numerator is higher than degree of the denominator. So think of things where we have, like, just regular polynomials where our denominator is 1 essentially. We would always fall into this category, and that's why for polynomials we never can have any horizontal asymptotes, or any other asymptotes for that matter, but definitely not any horizontal asymptotes, because those would always fall into this category. But there are some function over functions that are going to fall into this category too, where we have a larger degree in our numerator but we still have a non-zero degree in our denominator, and that would also fall into this category where there is just no horizontal asymptote. Okay, so there's one last one, and it's oblique asymptotes. It says an oblique asymptote is a slanted line, right? So oblique just means it's some line that can have any slope, right? So an oblique asymptote, it's like plotting an oblique asymptote is the same as just plotting any line, except an asymptote, of course, is not the actual function; it's a line that we're approaching. And a function f of x has an oblique asymptote if and only if the highest power in the numerator of f of x is exactly 1 degree higher than that in the highest power of the denominator. So for example, here we have degree 2 on top and degree 1 on the bottom. And here we have degree 5 on top, degree 4 on the bottom. So these are examples where we would have an oblique asymptote. Now, how do we find what the oblique asymptote is? Because all they say here is that there is one. They don't actually tell us where it is. So how we would find out where it is we would actually use a method that we used in our last unit. And that's partly actually why I wanted to do last unit before this one, is so that we could actually find the oblique asymptote. We have to actually do long division to find out what our solution is, and that's going to be our oblique asymptote once we do that long division. And we already know how to do long division from the previous unit. I will say I won't throw a lot of oblique asymptotes at you. There won't be a lot of long division in this unit, but it is good to know that that's the method that we would use to find them if this was this specific case. Something else I want to point out is that it is impossible to have both a horizontal asymptote and an oblique asymptote at the same time. Now, how come that's impossible? Well, if we have, for an oblique asymptote, the degree of the numerator must be exactly 1 higher than the degree of the denominator. And anytime we have the degree of the numerator exactly 1 higher than degree of the denominator, that means that it is higher than the degree of the denominator. And if it is any higher, whether it's 1, 2, 3, 4, any number higher, then that means there's no horizontal asymptote. So we can never have a horizontal asymptote and an oblique asymptote in the same graph. If we've concluded that there is a horizontal asymptote, that means there's no oblique asymptote. And if we concluded that there is an oblique asymptote, there's no horizontal asymptote. But it is also possible to have neither of them. There are cases where we don't have any horizontal asymptotes or oblique asymptotes. Also, with horizontal asymptotes or oblique asymptotes, there can only be one, right? So there can't be two different horizontal asymptotes or two different oblique asymptotes or anything like that either. Whereas as for vertical asymptotes, there can be lots of them, right? Because if we think about how many x-intercepts could a function have, well, the maximum would be that degree. So if we have a degree 3 polynomial, for example, in our denominator, then we could have up to 3 asymptotes. If we have a degree 4 polynomial in the denominator, we could have up to 4, and so on. So, there can really be an infinite many. Maybe I shouldn't say an infinite many, but there can be as many as we want there to be, right? Depending on the degree. There can be maximum the degree of the denominator, and the degree of the denominator could be, technically it could be 100 for all we know, so there could be 100 technically. Now, you wouldn't actually get a question with 100, but my point is there's not really a limit to how many vertical asymptotes there could be in a single question. It's only limited by the degree in the denominator, whereas for horizontal and oblique asymptotes there can only be one maximum of one of them, right? And that's it. Once we have one horizontal asymptote or one oblique asymptote, we're done. There's no more of either of those kinds of asymptotes after that. Very good. Okay, so let's get into some examples here. This first example says determine all possible asymptotes for this function. So let's start with vertical asymptotes. What would the vertical asymptotes be here? So the vertical asymptotes, there would just be one. It would just be that x would be equal to 4, right? Because when x is equal to 4, we have 0 in our denominator. In that same point, x equals 4 does not make 0 in the numerator. We can't cancel x minus 4 out with negative 3x. It doesn't work like that. So our vertical asymptote is x equals 4, and that's our only one for this example, right? Because this is linear, and so there's only one possible vertical asymptote here. Okay, what about horizontal asymptotes? Do we have a horizontal asymptote? Well, horizontal asymptotes depend on the degree of the numerator and the degree of the denominator. So in this case, the degree of the numerator is 1, and the degree of the denominator is also 1, right? These both represent a line. So what do we do when the degree of the numerator and degree of the denominator are the same? Well, what do? We take the degree of the numerator, the coefficient of that highest degree term, which in this case is negative 3, and then we take the coefficient of the highest degree term in denominator, which is just x, so there would be an invisible 1 here. So the horizontal asymptote would be negative 3 over 1, which is just negative 3. Awesome. So that's how we would do the first one. Let's move on to another example. Here it says determine all possible asymptotes for this function. Okay, so for this one, we have to first of all determine, is there any way that we could have x cubed, x cubed minus 8, or sorry, plus 8 equal to 0, right? Is there any possible way for that to happen? Because if there is, and it's not something that can cancel out with our numerator, then we have a vertical asymptote on our hands. Okay, so therefore, oh, x cubed equals to negative 8, and the cube root of negative 8 would be negative 2. So therefore, we have a horizontal asymptote at x equals negative 2, because that's the only point that if we plug it into x, we will get 0 in our denominator. And negative 2, if we plug that into our numerator, that gives us negative 2 in our numerator, not 0, right? And so therefore, that is indeed an asymptote and not a hole. Okay, what about, oh, sorry, I put HA. I should have put VA for vertical asymptote. But speaking of horizontal asymptotes, what is the horizontal asymptote here, if at all, if there is even one? So we know that if the degree of the numerator is higher, then that means that there's none. If the degree of the denominator is higher, that means there's one at y equals 0. And if the degrees are the same, it's the leading coefficients. So in this case, degree of the denominator is 3, and the degree of the numerator is only 1, right? And so that means degree of the denominator is higher. And whenever the degree of the denominator is higher, that means we have a horizontal asymptote at y equals to 0. Very good. And we're done, right? Because as soon as we have a horizontal asymptote, we don't have an oblique asymptote. So we're done. Okay. The next one here says for this function, determine all possible asymptotes. So first of all, for vertical asymptotes, where would our denominator be 0? Well, at x equals 2, the denominator is 0, and the numerator would not be 0. If we plugged in 2 to the numerator, in the numerator we'd get 8 plus 3, which is 11, which is certainly not 0. So we're good there. Then what about horizontal asymptotes? Well, let's see. Which degree is higher? Is it the degree of the numerator or a degree of the denominator? Or are they the same? So in this case, we have line over line, right? So the degree is the same. It's both the same, so it's just the coefficients of the leading terms. So that would be 4 for this one, and then there's an invisible 1 in front of this x, so it would just be y is equal to 4, right? Because 4 over 1 is just 4. Awesome. Okay, then let's move on to example 4. Example 4 says, for this function, determine all the possible asymptotes. So first of all, what's our vertical asymptote? It would be x equals to negative 2, because if we plugged in negative 2 to the denominator, we would get 0, and that's not possible. And if we plug that into the numerator, we don't get 0, so there's nothing we can really cancel out here, okay? And what about for a horizontal asymptote? Are there any? Well, in this case, the degree of the numerator is greater than the degree of the denominator, and so there are no horizontal asymptotes. Now that since there's no horizontal asymptotes, there might be an oblique asymptote. Okay? So if there's an oblique asymptote, if the degree of the numerator is exactly 1 more than the degree of the denominator, and in this case that is true, right? Because degree of the numerator is 2, degree of the denominator is 1. So what do we do here? We're going to do our division to figure it out. We're going to do x plus 2, and then over here we're going to do x squared, and then plus 0x plus 0, right? So just x squared. And now we're going to do long division. So how many times does x plus 2 go into x squared? Well, x times x is x squared, and 2 times x is plus 2x. And then we subtract and we get minus 2x. How many times does x plus 2, does x go into negative 2x? Well, negative 2 times. X times negative 2 is negative 2x. And 2 times negative 2 is negative 4. So we end up with 4 as our remainder. Or do we? One moment. Yes, we do end up with 4 as our remainder. Yes, we do. Okay, so therefore, what is our oblique asymptote? Our oblique asymptote is going to be x minus 2. So we have an oblique asymptote at y equals to x minus 2. And there we go. Okay, so next let's move on to this example here. First of all, are there any vertical asymptotes? Well, the obvious answer would be to say, oh, yes, there is, and it's at x equals 5. But I want to make sure that there's not actually a hole at x equals 5 first. So I'm just going to factor my top. It's a difference of squares, so it factors like this: x plus 5, x minus 5. Well, actually, turns out these cancel, right? Turns out that if we plug in x equals to 5, then we get 0 in our numerator and 0 in our denominator too. And so that actually means that there is a hole at x equals 5, and therefore there is no vertical asymptote. It's because we found out that the only possible vertical asymptote candidate is actually just a hole. Okay, now let's move on to horizontal asymptote. So there is a horizontal asymptote if and only if the degree of the numerator, right? It depends on the degrees, right? So in this case, degree of the numerator is higher than the degree of the denominator. And so that means there are no horizontal asymptotes. Now, what about an oblique asymptote? Well, at first glance, it seems like, well, maybe there is one. However, we already canceled out the x minus 5. So what we have left is just y equals x plus 5. And y equals x plus 5 divided by 1 is just going to give us, the same thing back. So there's actually no oblique asymptotes here either, because we actually don't really have something we can divide, right? We don't really have something we can divide. We already factored and canceled out and realized that this is just, the graph is just a line, right? Y equals x plus 5 with a hole at x equals 5. And that's all it is. And so when it comes to asymptotes and holes, right, or when it comes to asymptotes with lines, well, there's never an asymptote when we have an equation of a line, right? It's just not going to work like that. Okay, let's move on to the next one. It says for this one, determine all the possible asymptotes. So first thing I'm going to do is I'm going to factor this. Y is going to be equal to x plus 1 times, let's see, we can factor this as x plus 1 times 2x minus 1. And so these cancel. So our only vertical asymptote here is going to be x equals to 1/2. Okay, x is equal to 1 or x is equal to negative 1 is a hole, not a vertical asymptote. As for horizontal asymptotes, there would be a horizontal asymptote at y equals 0 because the degree of the denominator is greater than the degree of the numerator. Even when we cancel the x plus 1 and x plus 1 out, we still have 1 over 2x minus 1, which means our new degree in our numerator is 0, and our new degree in our denominator is 1. So we still have a greater degree in our numerator, in our denominator than we do in our numerator. And therefore, we have a horizontal asymptote at y is equal to 0. And because we have a horizontal asymptote, we can't have an oblique one. So then we're done. All right. Well, good work today, everyone. I hope this was informative, and I will see everybody next day. Bye, everyone.